We are given two resonance forms for SOCl2, which is thionyl chloride, and we are asked which is favored by the octet rule and which by formal charge considerations. So we can start by discussing the octet rule. So I'll just go through each atom in each resonance form and see if it has an octet. So starting with resonance form 1, we have chlorine, which has 6 unbonded electrons and 2 due to bonding. So it has an octet for both of these chlorines. Oxygen also has 6 electrons that are unbonded, 2 due to this bond. It has an octet as well. And sulfur has 2, 4, 6 electrons due to bonding, 2 due to the lone pair, so sulfur also has an octet. And moving on to the second resonance form, we have chlorine, which is unchanged. It still has 6 unbonded electrons, 2 due to the bond, so it does have an octet. Oxygen has 4 unbonded electrons and 4 due to this double bond, so it has an octet. But now sulfur has 2, 4, 6, 8 electrons due to bonding, plus another 2 due to this lone pair. So sulfur doesn't have an octet. So I'll write this here. And this is because it actually has 10 electrons. And the reason this is occurring is because sulfur can have an expanded octet. It's one of the rare cases where that can happen. But regardless, to figure out which is favored by the octet rule, resonance form 1 has every atom fulfilled with an octet. So 1 is favored by the octet rule. And now we can move on to the formal charge considerations. So when we're trying to find the formal charges, we can use a formula, which I'll write here. So the formal charge equals the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So a couple things to look out for when assessing formal charges is that low charges are favored. Additionally, we want negative formal charges on the more electronegative atoms. And so, additionally, if we have a neutral molecule, which we do in this case, all of the formal charges need to sum to 0. So we also want to look out for that. So I'll start calculating the formal charges for each atom in each resonance form. So starting with the first resonance form, chlorine has 7 valence electrons, and in this case has 6 non-bonding valence electrons, and then 2 bonding electrons, which we'll divide by 2 based on our formula. And we get that chlorine has a 0 formal charge. We can do the same thing for oxygen. Oxygen has 6 valence electrons. 6 are unbonded in this situation, and 2 are bonded. So this gives us a formal charge of -1 for oxygen. And then finally for sulfur, we have 6 valence electrons. We subtract 2 that are non-bonding, which is this lone pair right here, and then we have 6 that are bonding. So we get a formal charge of +1. And this does make sense because oxygen is very electronegative, so it's going to have that negative formal charge. And then if we sum all of these formal charges, we do get 0 because we have a neutral molecule. So this does follow the rules that we need to look out for. So now looking at the second resonance form, we can start with chlorine again. And this is still unchanged. We have 7 valence electrons, 6 that are non-bonding, and then 2 that are bonding. So we have a 0 formal charge for chlorine. For oxygen, we have 6 valence electrons, and we now have 4 that are non-bonding electrons. So we're going to subtract 4. And then we also have 4 that are bonding in this case. So we get that oxygen has a formal charge of 0. And then sulfur, again, has 6 valence electrons, and we have 2 that are non-bonding, and now we have 8 that are bonding. So we're going to get that sulfur has a formal charge of 0. So this configuration is actually more favored because all of the atoms have a formal charge of 0. So resonance form 2 is favored by formal charge considerations. I do want to note as well that in this scenario, formal charge considerations actually take priority over the octet rule. So the second resonance form is more stable. And although it doesn't follow the octet rule, sulfur can have an expanded octet. So it is still stable and it is still valid for sulfur to have 10 electrons. But our answer is that resonance form 1 is favored by the octet rule, and resonance form 2 is favored by formal charge considerations.